Hello, so this is Dr. Church, and we're going to take a few minutes today and talk about the relative motions of the Earth, Moon, and Sun. So, pretty cool studies. One of my favorite things at night is to go out and just look at the moon. I can't tell you how many hours I've looked at the moon, and as I have traveled in various places throughout the Earth, sometimes being very far from my family or feeling kind of alone. I don't know. I've always just taken comfort in looking up at the moon and knowing, hey, that's the same moon that my family's looking at tonight, and it's fairly predictable up there as it revolves around the Earth. So let's just take a look at some of the motions of the Earth, Moon, Sun system today. Well, how is the Moon moving relative to the Earth? If we were to stand at the North Pole and look up, we would see an elliptical orbit. It is clockwise when viewed from the North Pole. The distance, because of the ellipse, varies by about 6%, but on average, the distance of the moon from the Earth is about 384,000 kilometers, 238,000 miles. It took the Apollo astronauts, I think it was between 3 and 4 days to get from the Earth to the moon for the Apollo mission. So it's quite a ways away. So if you've ever looked up and wondered, well, how far away is that thing? Well, it's a little over 238,000 miles. The interesting thing, if we looked at the geometry, the Earth and the Sun, sorry, the Earth and the Moon rotation, as the Earth is fixed there and the Moon is going around, we can actually draw a plane. It's moving not just like around the center of the Earth. It's actually tilted at an angle. This is called the ecliptic. It is an imaginary plane connects the Earth's orbit with what's called the celestial sphere. If we were to look out at the stars, I don't know if you've noticed this or not, or you knew this, but when we look at the stars, they look to be fixed in space. The ancients looked up there and they called that the celestial sphere. It looked as if it's fixed in space. It doesn't move. That's why we can navigate according to the North Star. But now the moon and the sun, they do not look like they're fixed in space. They are moving relative to the Earth, and they're actually are, depending on how you look at it, what's moving relative to the other. If we're looking at them from the view of the Earth, they look like they're moving. Now we can define fixed points in space and look at relative motion, and we do that, and that gives us what's called the plane of the ecliptic, and we can trace the moon's rotation around the Earth along that plane. Now, the inclination of this plane is what gives us those relative motions. We know that the Earth is tilted and that the moon is rotating relative to that tilt, and that's how we can explain that geometrically. Now there's the what's called the perigee. Remember, it's an elliptical orbit around the Earth, and the perigee is the point at which the moon is closest to the Earth, and the apogee is the point at which the moon is furthest from the Earth. And that's why the moon will sometimes look like it's different sizes, because when it's closer, it looks about 14% larger than when it's further away, because that's a fairly significant distance it's traversing there. And the other thing that you'll notice too is when the moon is low in the sky, just right close to the horizon of the Earth, it will look huge. And then as it moves upwards, as the Earth is moving in this, and the moon is moving there, it'll look like it gets smaller as it gets higher in the sky. Well, you know that there are phases of the moon. I'm not going to spend a ton of time on this. You probably learned this in elementary school, and then learned it again in middle school, and probably sang songs and drew pictures and made flip books, and probably did a project. At least I hope you did. But again, you've got a progression of changes of the moon's appearance. These are what's called the lunar phases. If we start here with the moon being dark, let me throw a little circle on here so we can show that. Um, no fill, let's make it red. If we start here on the new moon, okay, it's going to look dark. That means that the moon is right between the earth and the sun. These yellow lines represent the rays of the sun. And so when the moon is between the earth and the sun, then the sunlight is of course on the back side of the moon, and the moon to us, when we're looking up, it looks dark. Now, as the moon moves around, then we have what's called the crescent or waxing moon. So it's going to have that crescent shape, and then part of it will be illuminated, the other part dark. And then you go through the first quarter, which is half illuminated, half dark. And then we have what's called the gibbous or waxing moon as the lit portion moves away and the dark becomes smaller and smaller. And then the full moon, at which point it's the exact opposite. The sun's rays are shining on the front side of the moon, which faces the earth, and so it will be completely lit, and it's full moon. Love that. It's beautiful at night. And then again, it'll start to wane again as it becomes darker. It'll go into that half and half scenario, and if you notice, they're exact opposites. Whereas this one is lit on the right and dark on the left. This one is lit on the left and dark on the right. And then as it moves further along its path, then it continues to wane and get darker and darker until eventually it comes back to the new moon. And that takes roughly a month. You know, that's what we would define as a month. Now, interestingly, the month is defined in two different ways. You've got the synodic month, which is based on the cycle of the moon's phases. That's from new moon to full moon, back to new moon. That's one cycle, and that will take us through all the phases of the moon, and that takes 29.5 days. But there's what's called the sidereal month, which is the true period of the moon's revolution around the earth, which only lasts 27 1/3 days. So it takes the moon only 27 1/3 days to make one complete revolution around the earth. Well, what's the difference there? Well, that's attributed because it's not following this exact, because the sun and the earth and the moon are all moving, right? The length of a daylight at any point is about 2 weeks on, well, that's 2 weeks on the moon. That's something different. The length of that, because of the relative motion of the earth and the sun, right? The earth is orbiting. You see, the earth is moving around the sun. The moon is moving around the earth. And because of that movement of the earth along its path and the movement of the moon around its path, it takes about two and some odd days to get completely around, to go through its complete phases relative to the sun, but only 27 1/3 days to go one revolution around the earth. So that movement of the earth as it goes around the sun is what accounts for that extra couple days. So it's like something you're trying to catch up to someone who's moving, and they're moving away from you, versus if they were standing still, you could catch up to them quicker. So with the sun relative to the, oh my goodness, there's too many objects to think about here. With the earth relative to the moon moving, then that's 27. But when you're rotating around the sun, then it's 29.5. So you think about that one. I'll probably try to throw up a graphic for you about it. All right, the difference between the 2 days we just talked about is because of that relative motion. But now, one of the things that you need to know is that we talk about the face of the moon, okay? Because the rotation, the moon is actually revolving on its axis and rotating around the earth. And because those rotations are exactly synchronized, it's fascinating. The front side of the moon always faces the earth. What's called the backside of moon. There's a famous rock album back in the day called The Backside of the Moon. and that is the dark side of the moon. It's the moon that we never see facing us. It's dark to us because we never see it. The only people who've ever seen that would be your Apollo astronauts who have gone over there. Now, all the Apollo missions were actually conducted on the front side of the moon, so you know we could see that part. But the astronauts that flew around back there, of course, probably some satellites have taken pictures back there as well. Okay, let's move on. We'll finish up with eclipses. Solar eclipses, well, that's when the moon moves between the Earth and the sun, casting a shadow on the Earth. A lunar eclipse occurs when the moon passes through the Earth's shadow. Now, one good way to remember that is what does the word eclipse mean? Well, it means to cover over. And so a solar eclipse is when the sun gets covered over, and a lunar eclipse is when the moon gets covered over. So if you have trouble remembering which is which, just think of it that way. During a new moon or a full moon phase, the moon's orbit crosses the plane of the ecliptic for an eclipse to take place. That's when the moon is directly between the earth and the sun, and that will create that shadow. Now, the maximum number of eclipses in a year would be 7, but the normal number is 4. So let's just look at a picture of that quickly, and we will be done. So here's sunlight coming in, again represented by the yellow arrows, and when the moon is between the sun and the earth, then it casts a shadow, right? And that's a solar eclipse because the moon is blocking the sun. Now, interestingly, the sun is about 400 times bigger than the moon, but the sun is about 400 times further away than the moon is. And so, roughly from Earth, they look about the same size. And so, when they're just right, you can have what's called a full solar eclipse, which is the most dramatic of all the eclipses for sure, when the sun perfectly sits, I'm sorry, the moon perfectly sits in front of the sun. Hey, you try it and see how easy it is to get tangled. Okay, when the moon sits directly between the sun, then that's a full solar eclipse. And then finally, the lunar eclipse is when the earth becomes between the sun and the moon, and the earth casts its shadow onto the moon, and it will block out the illumination of the moon somewhat, and that's a lunar eclipse. Okay, so there's just a little bit about the relative motions of the Earth and the Sun and the Moon, and some interesting things maybe you can file away in your memory bank. I love studying about the moon. I did want to be an astronaut back in the 70s when I was a little kid. Unfortunately, all those missions to the moon were over long before I got through the Marine Corps and engineering school and even thought about that. But hey, maybe one of you can be an astronaut. We had an NC State graduate that just spent a significant amount of time in space. Lady there, and pretty proud of her. So maybe one of you will get the bug and want to go to space one day, and I think you can. So I hope you learned something today, and you enjoyed the lesson.